Today we're going to talk about Gigabyte's thermal gel from hell. For those looking for a high-end custom gaming experience, look no further than Falcon Northwest. Falcon Northwest has been building PCs made for gamers for over 30 years with a focus on a true high-end gaming experience. Custom cases available only through Falcon Northwest feature state-of-the-art testing and design to ensure that every component is performing at their best through thermal imaging and rigorous lab testing designed and overseen by the Falcon Northwest founder himself. With a complete lineup of systems ranging from small to large, every Falcon Northwest system includes a 3-year warranty policy and a year of 2-way overnight shipping coverage, providing the ultimate peace of mind. To see all that Falcon Northwest has to offer, follow the sponsored link in the description below. This story's kind of been going on for months now. Gigabyte/Aorus, if you don't know, Aorus and Gigabyte, they're the same company. Aorus is like the premium brand under Gigabyte's like parent company. That's why the Aorus products tend to cost more. But specifically on the graphics cards in the 50 series, they decided to like not use thermal pads anywhere, and they decided to go with what they're dubbing high quality server grade thermal gel. I don't know why they're even calling it a gel. It really is a putty. Like gel to me I think of like liquidy and oozy. I guess the problem is the putty's turning liquidy and oozy for a lot of people. So if you look at some of these images right now that we're putting on screen, what's happening is I'm assuming the graphics cards get warm, the gel starts to liquefy, or I don't even want to call it gel, it's a putty. The putty starts to liquefy. There is oil content and you know other things inside there that have liquid properties to them. And so it seems like as they get warm and maybe long duration in a vertical position, it starts to pump out. Now, pumping out with thermal paste is kind of normal. A lot of thermal paste has some phase change-ish properties to it. Like the cooler it is, the thicker it is, the hotter it gets, the more liquidy it is. And with the constant pressure of having a cooler pushing down on the die, over time, as that phase changes, or I should say the viscosity changes with temperature, it starts to pump out around the sides, and over time you have to replace your thermal paste. That's why GPU manufacturers tend to use a much harder, much more dense thermal paste to stop pump out. That's why sometimes you have to practically scrape it off of the GPU when you go to change or repaste your GPU, which is why if you use more liquidy paste like KPX and such, over time that can pump out faster, but that's designed to be an extreme thermal interface material to use for like extreme cooling and such, because it doesn't get hard as it gets cold. There's a joke in there and I'll let you guys write it. Anyway, this isn't the first time though we've seen a manufacturer use thermal putty in different aspects of the GPU when it comes to like cooling the VRMs and cooling the memory and maybe cooling the MOSFETs. This is actually thermal putty from an old EVGA graphics card. It's, I believe it was a 3090. They were using thermal putty on some aspects of it. And because I was constantly taking the coolers off for like XOC stuff, this was some of the replacement stuff they had sent me. So as you can see, it's basically just chunks of thermal material. And the reason why they use putties is rather than going through all of the measurements needed and ordering all of the different size, thickness thermal pads, they just put putty in there. That way when the cooler goes on, it just smushes down and fills the gaps. There's a lot of questions and that still need to be answered over time with whether or not thermal putty is as good as a thermal pad. In fact, I've even had the discussion with Der Bauer, you know, the founder of the Thermal Grizzly, right? This is this Cryonaut stuff. I've got his thermal putty right here. But when I had a conversation with Der Bauer when he sent me one of the earlier prototypes of the Delta Mate water block that's currently on my 5090, previous videos he had shown he was using thermal putty on the VRMs and stuff on his block. And then when I received it, I got thermal pads. And he even said he found that the thermal conductivity of the pad was better than even his own putty. So that's why he ended up going with thermal pads and not the putty. So that's why it's still an interesting decision for a mainstream manufacturer like this to use thermal putty. Now what we're gonna do here is we're gonna tear this one down. This is the Aorus Master 5090. I've been running it now for a few months. I featured it in a couple of videos where I showed how to flash this with like an XOC BIOS, and I ran 1,000 watts to it on air with the air conditioner. So it's seen some pretty extreme temps, and that's the condition at which I find it might pump out the putty. But I've been running it in my workstation upstairs, but in a standard horizontal position. So I have a feeling mine's gonna probably look fine, simply because of the fact that the issue is going to be gravity assisted, because obviously if it's gonna squish out this way, gravity is not gonna be trying to draw it down. So I don't think this one's gonna be a problem, but what I wanna test is I've already done a full temperature run on this. The only sensors available on this graphics card, even at $2,500 or $800, whatever this card was at the time. They've come down a bit. Actually, I think this was a $3,000 card. Anyway, I digress. Only gets us memory junction temperature and GPU temperature. As you know, 50 series, NVIDIA removed the hotspot temperature sensor. At least it's not visible to us. I'm sure it's still there, but it's not visible to us. But there's no VRM temperature or individual memory sensors that are available to us on this. Just a single memory junction temperature, which is probably reporting the hottest memory, and then no VRM. So that would have been nice to be able to see what the VRM temps look like before and after, but I can only see GPU and memory on this card. That's it. And that's through hardware info, that's through GPU Z, all of it. That's the only sensors. So with that said, let's go ahead and do the teardown. Just to show you how much of this is liquid in there, we're gonna look right here through the gap.
Ew.
Holy cow. Oh, dude, there's so much of it.
That's like a whole tub of it.
I don't think I have enough to replace it. This is a first for me. I have never seen something like this before. Okay, I'm just curious if there's any on the back plate. So far, I don't think this is gonna be a problem for people that run their graphics card in horizontal, but clearly those that... What's the point of the back plate? Okay, sure. Let's just insulate the card. Now, the temperatures on this card were actually really good, but it's just like, what's the point of the backplate then? Okay. Very important when you're doing this sort of stuff, take a photo. So, to clean this off, we're just gonna kind of scrape gently. It's very liquidy. Okay, I can kind of understand now. I feel like I should save this putty or something, but yeah, it's very liquidy. It's like halfway between paste and a thermal putty. Because it leaves the remnants on your fingers as if it were thermal paste. And this is not even the same stuff here. Wait, is that liquid metal? I think this might be that hybrid stuff. There are thermal pastes out there that have like a liquid metal in it to help with the thermal conductivity. So now it'll be interesting to see if by getting rid of the potential of this oozing, did I now hurt my GPU's overall performance now because of the fact that I'm removing this hybrid compound? I might actually not have enough. That's what came off the card. It's like, it's got weight to it. 48 grams of thermal putty, 44 grams. So that is a very clean PCB versus what we had a second ago. This might be one of the coolest, no pun intended, actually yes, pun intended, cool air coolers we've seen. It performs really, really well. I do have a chart that we'll be showing after I do the comparison because I haven't done it yet, but you can see all the dimpling in here too. Like this whole giant thing is a vapor chamber. Like that is a big vapor chamber. In fact, the amount of dimples, or what are they called? Like they're like the spires that are in there, right? So much bigger than even the GPU substrate itself. But now I'm wondering if I should apply the thermal paste to the GPU cooler or to the PCB. I'm thinking that it was applied to the cooler maybe when they did it. I'm also really curious now as to whether or not I've hurt the GPU temps a little bit by not having this hybrid compound that, yeah, they do mention on their website. I really hope I have enough. Otherwise I'll be mixing and matching two different kinds because I'm not reusing their stuff. But I am gonna use the Thermal Grizzly. I think I'll just do it on the PCB. So what I'm gonna do now, I'm just gonna compare. And yeah, you can see there's like really fine scratching on there. That's just because of the plastic. When I like scrape some of it off, you can't even feel it with your finger. It's just because that was a polished edge. And obviously because I couldn't dip the cooler in my ultrasonic cleaner and use a brush like I did with this, that's why there's still some remnants of the putty on there, but I don't think that's gonna be an issue. All right, I'm gonna take my picture and start oozing. This is the first and last time I will ever work with this shit. I'm telling you. So yeah, as you can see, there's a mixture of different types of putties on there because I did not have enough, just like I thought. So I used all of the DeBauer stuff, but I made sure to use the DeBauer stuff on the memory chips, which is the only thing I had the temperature readouts for. And then I used the EVGA stuff and then actually reused a little bit of the the Gigabyte stuff, which is at this point, this video is more now about what you're gonna deal with if you ever had to change your thermal paste. This is a terrible, terrible design. Whether we're talking about, and look, the bits of it are everywhere. And it wants to stick to itself, so it doesn't want to stick to the components, it wants to stick to your gloves or your fingers. So I had to keep like putting alcohol on my gloves and like getting all the, not the condensation, but the bits of it off, otherwise it just kept wanting to stick. This is like thermal paste from hell, essentially. I mean, look at this, it is literally everywhere. This is a brand new gaming mat that I brought out from inventory, and it's on the chair, it's on my legs, it's just, anyway, how much of it's gonna fall off when I tip it over? Okay, nothing so far, that's good. Because I still have to get it onto the card. Yeah, some of it's on the cooler. I started by trying to apply it to the cooler. A little bit just fell off right here. I started trying to apply it to the cooler first, and then that was turning out to be a complete pain in the butt. So now I'm just like, you know what, we'll put it on the PCB first. But now I gotta plug in these connectors. Yeah. But first I have to do the back plate. I was about to really mess myself up, because if I touched it on there and then it started to like transfer, I have to do this first. Because this is a really dumb design in the way the cooler goes together and comes apart as far as I'm concerned. So let's see if I can get this all back on there now. Oh, it's...
So, never again?
Never again. No, Gigabyte, fuck you. All right, so let's talk about the temperatures. I really wish there were more sensors that were visible on this card. God, for such an expensive flagship card for a brand, I'm shocked that there's not more sensors available to us. I mean, every other 5090 so far, with the exception of like the Zotac, they've had other sensors available to us. So, as you saw, the installation of reputtying it is a complete nightmare. Like, it is just bad. And even watching videos of people trying to reputty their cards, man, they're like loading in a syringe and like trying to like frost it like a cake almost, like, you know, put dollops of crap everywhere. These are installed in a factory, like they're applied in a factory that basically has perfect placement to just like bloop, 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 bloop everywhere it needs to go. And then the card goes together, and as you saw, it came apart and looked like grilled cheese. The temperatures though, let's talk about this. So first of all, the core, we have two things we're testing here, because to reputty it, if you're getting the oozing gel problem, means you're going to lose the hybrid thermal compound that's in there, which is like a thermal compound paste / liquid metal. And we did see a rise in GPU temperature because of that. In fact, we saw it's about 3 degrees. So our average temperature was the stock setup without touching anything on the core was a 52.67 with a 75% fan curve set to static, 22C ambient temperature, and that is with the Firmark 2.9. And I've no longer made it so that the core drops down. The core will go to its max clocks. And that is compared to our 55.54 with the KPX. So about a 3 degree increase, about 2.9 degrees, which is not abnormal. It might have been as high as like 5 degrees if that were a like true liquid metal compound. So nothing to like get super upset about. In fact, it doesn't even, if you look at the clock speed chart here or graph, you can see on the clock speeds, it just really had no difference whatsoever. You can see the blue line a little bit above the pink line for like the first third of the test. That is with the hybrid compound. But then you can see once everything like reaches equilibrium, you know, and everything's normalized in terms of the temperatures and the power draw and stuff, they basically follow the same line. So 3 degrees is not enough to really affect the boost bin. So, I mean, even if it was to affect anything, it would be 1 boost bin, which is not, when we're talking 3000 megahertz is where it starts at and then drops to about 2950. I mean, you're not gonna notice 15 megahertz at those clock speeds. But it's just worth noting, you know, if you're trying to squeeze every ounce of temperature improvement out of your graphics card, we kind of went the wrong direction with that. But we didn't have a choice, because if we needed to reputty, that's gonna come apart anyway. Now, if we talk about the memory temperatures here, our average memory temperature, and remember, this is one temperature sensor, so I don't know if this is the hottest memory temperature, it's calling it memory junction temperature, so I'm assuming it's gonna be maybe an average, not entirely sure, but if you look at something like the Asus Astral, we can see each chip's temperature And then we can also see the VRM temperatures for both memory and core. So there's just not a lot of information available to us on this. Anyway, at stock, our memory junction temperature went from a 60.71 over our 15-minute test in Furmark up to a 61.08. So no real temperature change between the Thermal Grizzly putty, advanced putty that I use, that's the blue putty, versus the stock putty that's already in here. But again, there was nothing wrong with our card because we never really ran it in vertical orientation. It spent most of its time in horizontal. So I can't say whether or not we would have seen hotter temperatures had that putty started to ooze. I would assume because the only reason it could even potentially move means there's a pretty large gap between the two, so there's not a lot of surface tension keeping it kind of adhered to where it's supposed to be. But applying the thermal paste is a complete pain in the ass, and getting it to stick to like the memory modules and the VRMs and all that is very difficult. It wants to slide around and move. So it makes sense to me that if it starts to liquefy more at a higher temperature, then it would start to drip in this orientation here. But obviously, because our card hadn't started to do that, I don't think we started to see any thinning of putty between those two materials, or those two surfaces, if you will, which is the cooler and the component. But maybe if someone has putty oozing in their card, they would see those temps rising because you're getting less material between those two surfaces. But it would also really only show in like the bottom, because the bottom is where it's coming down. Otherwise, it's just going to slide across itself, if that makes sense. So maybe it wouldn't even shown then, unless that putty starts to drip down into like your PCI Express slot, which would be a complete pain in the ass versus thermal paste. But if we look at the chart here, or the graph over time, you can see on the memory, it is ever so slightly lower on the average, but that's because of the fact that you can see it gets these low spikes. Whereas the pink line here, we get a few of the high spikes of 1 degree towards the end. But all in all, it follows essentially the same pattern. But we did lose performance in quote of temperature performance, quote of whatever, in relation to temperature performance, because of the fact that it's not as thermally conductive when it comes to our GPU paste that's on there. And then the putty, that could just be an installation thing. That could have just been a variance thing. I could have probably taken it off, put the same putty back on, and gotten a different temperature. That's just because we disturbed it, if you will. It might get better over time too, because that putty might start to kind of settle into places it needs to settle. But again, 0.29, whatever it was, degree is not, that's nothing to worry about. Also, should you be worried about this? Well, I think if you're running your card, long gaming sessions in a hot environment with a hot case, vertical, then potentially. I mean, the problem exists. It's there. There is plenty of evidence that the putty does migrate, and it migrates away from where it needs to be. That's the problem there. If you are just running a standard horizontal positioning like this, I don't think you have anything to worry about, because gravity is not helping draw it down out of where it needs to be. Do I think this is a non-issue? No, because it's an issue for plenty of people. Plenty of people have seen now that it can reach all the way down to the PCI Express slot. We've shown photos here of it literally looking like, GAC, just like running down the side of the graphics card. It's not pretty. I don't know why Aorus / Gigabyte chose this process of cooling versus just going with pads. Maybe it was cheaper for them to just load up a robot with a syringe on the end and just let it draw lines where it needs to and it's done, versus sourcing all the different height pads that it potentially need. And those pads are probably more than likely applied. I've never been to the factories, but they're probably applied by multiple machines, because they got to be loaded up with different thicknesses and different heights of those pads. The Z-axis height matters. So maybe it was a cost-saving move where it was just cheaper to, spooge all over the card, if you will, with thermal putty and call it a day. But I don't think this is something that was really thought through when it comes to a consumer use case and whether or not that's even necessary. They're the only brand, as far as I can tell right now, that is using putty everywhere. Like, we've seen some folks use putty in areas maybe where they're like, it'd be nice to have some cooling on this. Maybe it's not necessary, but hey, we can just use putty to get it done. Let's use putty everywhere. If you've been running a Gigabyte branded card or an Aorus card and you've had the putty ooze of, it's like Ninja Turtles, but all over your graphics card, sound off down in the comments below. I'm curious if you've noticed any sort of adverse effects of the putty oozing, and did you start to notice any sort of throttling or thermal problems with the memory? And the core would be fine, but the memory, that's all you can see. So tell me how it's been for you guys. My recommendation is if you're running one of these cards in vertical position, I don't suggest you open it up and try and redo it yourself. One, you would need to get several containers of putty to replace all the putty that's on here. Two, cleaning it off is a complete nightmare. The only reason I was able to get mine so clean is because I do have an ultrasonic, an industrial grade ultrasonic cleaner that is able to be completely filled with 99% IPA, and then I can get in there with a brush and just really clean it off. And then reapplying the paste is a complete nightmare. I just don't think this is something that the average consumer should have to deal with. Repasting a GPU is one of the quickest, easiest ways to inject life back into a really old card, maybe where that paste is cracked or it's just kind of thermally cycled itself out. The second you open this thing up, man, you are just asking for trouble. Anyway, there we go. Gigabyte, I don't know why you did this, but you shouldn't have done it because you've taken the consumer user serviceability out of it entirely. All right, guys, thanks for watching. As always, we'll see you in the next one.